Here we have midterm 2. A copper square loop with a sides of 0.01 meter, a mass, can spin freely around the center axis its square's plane. A current of 0.1 ampere is sent around the loop, and a uniform magnetic field of 0.12 Tesla is directed parallel to the plane of the square. What is the maximum kinetic energy that loop can acquire? Okay, now here we have a loop, square loop. The current is going, as you can see, clockwise, and magnetic field is directed to the left. Now, when there is a current is passing, and when you apply a magnetic field, what will happen? So what will happen is basically the force here. If you take this point, the force will be, pointing towards you, so it's difficult to draw it, so I will just say that it's like in this direction. Okay, actually it's pointing to you. Okay, or in other words, I can just say that it's out of the page. This is a force. Okay, it's out of the page, and if you take this part, it will be into the page. Okay, so if that's the case, then what will happen is that the angle between B and a current is 90 degree. Okay, so then it will try to rotate in such a way that it will be like, it will try to rotate in this direction. Okay, it will rotate in that direction until it will make a 90 degree, and then it will stop. Okay, so as you can see here is a 90 degree, so it will rotate until it makes a 90 degree and it will stop. Okay, okay, so now let's start solving it. We know that changing kinetic energy plus changing potential energy is equal to 0. Okay, now the kinetic energy initially it was not moving, so I would say that it's mv squared final divided by 2 minus mv initial squared over 2. Now initially, since it was not moving, I will make this one is 0, plus potential energy final minus potential energy initial, which is equal to 0. Now this one gives us kinetic energy maximum. Okay, kinetic energy max. Okay, where it will have maximum velocity. That means kinetic energy maximum will be equal to the potential energy initial minus potential energy final. Right, now the potential energy of magnetic moment is equal to the mu b. Now initially it was a 90 degree, so I would say sine 90 degree minus, it will stop when mu b sine is 0 degree. Okay, sorry, let me just clarify it. So 0 degree. Why it will stop is because when it makes a 0 degree, the force that will be acting on the loop basically will be pointing to this direction. If I'm correct, that one will be pointing in that direction. Okay, that means it will not move, so it will just rotate only 90 degree and it will stop. Okay, so we know that sine 0 degree gives you 0, so I will make it 0. So at the end we will have kinetic energy max is equal to the mu b sine 90 degree. Now mu is equal to the current area of the loop, b, and sine 90 degree. Now if you plug the numbers, you should get the right answer.